This is a relatively difficult problem. So we're going to go ahead and look at what we know here from the problem setup, okay? And it helps to look at the picture while solving this problem with me. We're going to go ahead and say that T1 on the picture is just F sub T1, T2 is just F sub T2, okay? We have the force of the crate that is pulling down on the smaller pulley in the dual pulley system. And we infer the mass of the crate just by dividing this number by 9.8 meters per second squared. So we have what we're looking for right here actually is the acceleration of the pulley, the rotational acceleration of the pulley. So in my mind, I'm thinking it's probably best to start off with Newton's second law for rotation and just see where it goes from there. So we're going to start off with N2 for rotation, see where it goes. As convention goes, we're going to make counterclockwise positive. So tau of the pulley net is going to equal to I of the pulley times alpha of the pulley. I'm going to then go ahead and break down torque into stuff that's a bit more familiar. Also, we need to acknowledge the fact that there are two torques acting on the pulley. There is a torque acting from the motor that's pulling the pulley counterclockwise, which is positive, and the torque acting from the weight of the crate pulling the pulley clockwise. So we're going to do Newton's second law for that dual pulley system. Let's go ahead and put the Ft1, that's the torque, or that's the force supplied by the motor pulling the pulley counterclockwise, times L1, which is the bigger radius, minus Ft2, that's the force supplied by the crate, multiplied by the smaller radius, L2. And that's going to equal to I of the pulley times alpha of the pulley. All right, let's go ahead and look at what we need to know. We're in luck because the thing that we need to find is right here. So we have our I on the prize. I pulley is known, L2 is, and L1 is known. Force of the tension from the motor is also known, but what we don't know is the force of the tension from the crate. So it looks like we're going to go on a little side quest to find that out. All right, in order to do that, we're going to have to look at a linear version of Newton's second law. And that's just because we're seeing that we have no other equations for torque. We only have that one, but we do have an equation for what the crate is experiencing. And hopefully that can guide us to finding this out. So we see that force on the crate in the y direction, net, so that's a lot of subscripts, is equal to the mass of the crate times the acceleration of the crate. Okay, looks like it's causing more problems than solving because acceleration of the crate, I don't know, we don't have anything with that, but we do have the need to find the acceleration of the pulley, the rotational acceleration of the pulley, which kind of relate to that. So I'm kind of feeling okay about this. All right, let's go ahead and look at the forces acting on the crate. We're going to go ahead and say up is positive, down is negative. So we have force of tension 2, that's pulling up on the crate. We got the force of gravity, it's pulling down on the crate. And we have that equaling to the mass of the crate times the acceleration of the crate. Cool, that's awesome. Let's see, now I'm confused. Okay, we're trying to find Ft2 in the side quest. We know Fg crate, we know mass crate, but we don't know the acceleration of the crate. Darn it. Well, let's go ahead and do a side quest. We've never done a side quest before, so why not start now? Side quest, how do we find the acceleration of the crate? And we can link it to something that we need to find or we already know. Well, I know from my studies that linear acceleration, and that's the acceleration that the crate is experiencing, is related to rotational acceleration of the thing that might be pulling the crate, that little pulley that's pulling up and down on the crate string. So we could say the acceleration of the crate is a function of the rotational acceleration that the pulley is pulling on it, multiplied by the radius in which the acceleration is being given from the pulley. So it looks like that radius is going to be L2. That's where the crate is hooked onto on the dual pulley system. So our side quest, we needed to find out what A is. We know what this is. Actually, we don't know what this is, but this is part of what we eventually want to find out. And we know what L2 is. So we're getting somewhere. Let's go ahead and plug all of this into the original equation. So here's the original equation. Here was our side quest that we now need to plug into F sub T2. And here's what we should plug in to A. So we're going to plug this into this. We're going to then plug this thing into that. And we're going to solve out for alpha Pulley. That's a long journey. So let's go ahead and do that with the limited space we have here. I'm going to start on the left. We have FT1 times L1 minus FT2 times L2. Oh crap, I already made a mistake. Instead of FT2, what I'm going to now do is say FG crate, since I put this on the other side, plus M crate. And now instead of A crate, I have to say alpha Pulley L2. That is a lot of nestling we did here. So let me try to make sure I got this straight. Instead of F2, I put FG crate plus M crate A crate. But then for A crate, I just put alpha Pulley L2. Is that what I did? Yes, that's what I did. So now let's bring down L2 from our original equation. It's a lot of complicated thinking here. And then we're going to say that's going to equal to I Pulley times alpha Pulley. Okay. Now, let me go ahead and take this out of the parentheses so we have all of our terms lined up. FT1 L1 minus FG crate L2, so I'm multiplying this by the L2 out here, minus, so minus plus, so that's a minus, M crate alpha Pulley L2 L2, which is just going to be L2 squared, is now equal to I Pulley alpha Pulley. Next step is to get all our pulleys in a line. That would mean that we need to get, I'm going to go ahead and put this pulley on this side and then have this be on the left side. Then I'm just going to flip it so I can have my pulley parameters on the left, just because I'm more comfortable seeing it that way. So I have alpha Pulley times I Pulley, oops, plus M crate L2 squared. So we got that right. And that's going to equal to FT1 L1 minus FG crate L2. And with the space I have left on the paper, let's try to get alpha as one universal term. So alpha Pulley is now going to equal to this thing divided by this thing right here inside the parentheses. So it's going to now be F T1 L1 minus F G crate L2 divided by I Pulley plus M crate L2 squared. And let's make sure we have all of the knowns here. FT1 is given there. L1 is given in the problem, and I didn't write that down, so I should have done that. L1 is given in the problem. FG crate is right there. In fact, let me write down the L1 and L2 now. L1 is 0.6 meters. L2 is 0.2 meters. So there's our knowns right there. Sorry, where was I? L2 is given there. I Pulley is given here as the 50. M crate is given here as a derived parameter from the force of the weight of the crate. And then L2 again is given there. So we basically have all of these parameters listed here or in the original problem. Now, solving it out, putting it in your calculator, we are going to get, and I'm just going to give you the 3 significant figure version because that's all I can literally write here. This alpha for the pulley is going to end up being 5.97 radians per second squared. And it's going to go in the counterclockwise direction since it's a positive value, it looks like. So let's go ahead and summarize what we did. We went ahead and we solved the problem using Newton's second law to try to get alpha. We figured out that we didn't have a component, so we took a side quest, used Newton's second law for the crate instead of just a pulley. Now we used it for the crate. Figured out that we did not have the acceleration of the crate, but we can easily fix that by equating acceleration to the rotational acceleration of the pulley that's pulling up on the crate. And we went ahead and plugged everything in to the original equation, and we solved out for alpha pulley. It's a very complicated process, so I'm going to just let you look at this for a little bit.